Hello to everyone. As many of today's speakers, I asked ChatGPT to generate some image cover, and I liked faces of these people. I just asked create Sims 3 Manifest V3 with Edguard. It tried, it tried hard, and Chrome. That's it. I have a speech, and I will read from the screen because without speech my presentation will be much worse. Let's start. I'm happy to welcome each of you and to be back in this event where we strive to keep the internet clean and safe. Today in my presentation I will tell you how we at Edguard transitioned our main extension with 14 million weekly users to MV3. I will discuss the cost of this transition, the decisions we made, and what we plan to do in the near future. Everyone loves numbers. The thing is, Edguard doesn't collect much analytics or telemetry, so the only numbers I can share are from the extension store statistics. Our move to MV3 started by taking the MV3 experimental extension and turning it into a new MV3 beta, then uploading the first version of our main blocker in MV3. After launching, the user base started growing by 10,000 users per week, purely from organic traffic. Initially, we thought that the main extension was losing users, but it turned out to be a seasonal drop, something like here. And this was just a summer. After updating to Manifest V3, we recovered the lost million users and even gained an additional 500 users. This graph shows the number of one-star ratings, the worst possible rating. Based on this graph, I invite you to guess when we transition our main extension to Manifest V3. Still hint that this is not like this because too far ago. And yes, it was in the September 2022. Our rollout strategy was as follows. We already had 2 listed MV2 extensions and 1 of MV3. To avoid losing the valuable listed MV2 extension, we decided to keep one of them, which was previously intended for MV2 beta. This gave us the following setup. MV3 release took over the MV2 release slot. MV3 beta replaces the MV3 experimental, and MV2 release with a new design took over the MV2 beta slot. This graph on the right shows how it transitions from version to version in more detail. Yes, we decided to keep the MV2 release for as long as possible. And let's now take a closer look at how we set up the build process to compile one extension for 2 different manifests. Put on your aprons, it's time to cook. We decided to build the extension for 2 manifests from a single code base. First, we added a new global variable that helped separate elements of the code base from business logic to tests and build processes. This helps keep the code base almost identical for both manifests. We then split the TypeScript configuration into 2 separate files to ensure proper type checking for manifest-dependent files. Those that couldn't be kept as a single file were easier to separate. Next one. To tie everything together, we reorganized the Webpack configurations. We created one large configuration file that containing all the shared build elements, entry points, resolvers, loaders, plugins, that's it. Here with the resolvers, we defined our manifest-dependent files using the new environment variable, this global one, which would be swept during the build processes. So you cannot detect it in the runtime. Next comes to the layer of manifest-specific build logic. The configuration for MV2 and MV3 differ more in this stage and are therefore smaller, mostly containing different entry and output points. Next step is the browser-specific configuration, where we define specific changes for the build. For example, this is where we add the use of our new linear rule sets library. which handles proper rule set assignments in the output manifest. Additionally, the output manifest itself is specified also here. And the final step was setting up the tests where we're able to use the same global variable for unit tests and, for instance, ignore logic testings that applies only to MV2. On our integration testing platform, available online on test cases at agrd.dev, we labeled all the tests as either suitable for MV2 or MV3. On this slide, I wanted to take a short break and shift away from the technical details by sharing a couple of reviews about new version of the extension from the store and from our filters creators. However, none of them made it through the censorship. So let's just move on. Next, I would like to talk about the parts of the extension that could have been lost during the transition to MV3, but we put in a lot of effort to retain them, also with a slightly reduced functionality. The filtering lock. This is one of the most important, if not the most important part of our extension that our filters creators use constantly. Based on information from filtering log, they can see which rules needed to be refined and which rules should apply to which requests. It's very useful in complex cases where blocking condition cannot be determined at first glance. The main difference in new manifest is that we can not longer display the exact rule that triggered in case of packed extension. For such packed extension, we have added a red asterisk as an indicator that this is an assumed rule. What does it mean? Meaning that the rule was matched by our ad filtering engine, and we assumed that it was applied in DNR form. To show the exact triggering text rule and its DNR form, we use onRule match debug callback, which only works in unpacked, manually installed extensions. How does it work under the hood? In a sense, we retained all of our rule matching processes for each request within TS URL filter, but made it not blocking as required by Manifest v3. Moreover, the rule matching work via web request API is very important for us to apply cosmetic blocking rules, which are currently not achievable declaratively. For each request, we calculate a special object called matching result, which contains both network and cosmetic rules. We keep the network rules for the filtering log and some use cases. For example, removing headers with cookies, as the DNR specification doesn't yet support all the necessary tools. And cosmetic rules are applied on the page via content script. We also had to rethink how we work with the web navigation API, but again, for the same purpose, to apply cosmetic rules as quickly as possible within the new manifest. For this, we start calculating a preliminary object with cosmetic rules in the very first callback for the page, which is then attached to each frame. Then we applied it as soon as the navigation finished and the frame starts loading resources. Finally, we clean up the matched rules, but with a slight delay in the filtering log if the filtering log is open, as onRule match debug triggers async with a small lag. So we need to store the matched rules to retrieve their text version. To extract the text version of the matched rule, we had to pack the rule sets in a way that allowed us to do this quickly, without using too much memory. From the browser API perspective, we only added one method, onRule match debug. But in terms of preparation, it's like an iceberg. 90% of work has to be done during the conversion stage to store the data in the necessary formats, so that we can quickly retrieve the text version of the rule for each matched DNR rule. In addition, to create the declarative rule set itself, we needed to store metadata. We decided to split this into two parts. The part we always need and runtime counters of the resulting filters, a separate list of bad filter rules that can work in cross filters, and something like this. And another part where we store the coordinates for extracting the text string from the original text file to get the text version of the rule. We load this data only on demand when the filtering log is open. New solution, new problems, but even this can turn it out to be too simple. I say this ironically. While developing MV3, we also work on storing our filters in binary format instead of text, which would significantly speed up the extension performance. However, when we aim for expedite review, we need to ensure that extension only contain changes in JSON files with declarative rules. Said and done. During one of the web extensions community meetings, the possibility of creating new fields with JSON files for service information was discussed. We decided to pack all our metadata into those fields. Yes, we're a bit crazy and packed binary data back into text format. My colleague David, be sure to attend his talk tomorrow on AG3 integration, came up with the idea of using the byte range mechanism to download only the necessary part of the file, thus maintaining fast file loading and initializing process. The final rule set with service information fields can be seen in the screenshot on the right. We create a fake DNR rule where we store all the data in the required fields. The filtering log could be much more useful and convenient if filter creators did not have to compile the extension from source, but could use the latest production version to be better understand our users' needs. Ideally, on-rule match debug should be enabled in the same way as the user script API, just by toggling developer mode in the browser settings. The second important part we managed to retain is dynamic rules. However, in our main extension, we have various types of rules that need to be applied on the fly. In the dynamic section, we currently include rules for quick fixes filter, which are downloaded every hour and contain critical hotfixes, at least until we set up auto builds using expedited review. Rules from the allow list section, which completely disable blocking on the listed sites. User rules and custom rules, this section hasn't changed since the experimental version, and we simply convert them on the fly. Simply. Here, I would like to focus more on how we keep blocking relevant under MV3. Before we started actively working on the transition to MV3, we were concerned about the traffic that users would have to download for filter updates, and to a lesser extent, the size of the hosting built for our company. To reduce this, we developed a special library for creating and applying diff patches, diff builder. We successfully implemented it in the MV2 extension, and the picture on the slide, which I carefully borrowed from uBlock, visually demonstrates how much less traffic is consumed. For example, the size of patches for our main filter contains about 10 to 15, maybe 20 lines, while the filter itself contains 100 of thousands lines. That said, if we want to move to auto builds and expedite reviews, this will require around 100 megabytes of traffic to be downloaded for every update. This is considering that we had to cut some filters to minimize the size of the extension, and it now contains only 40 filters. It would be ideal if the browser could support a similar mechanism for downloading updates via patches. Here is a small brief how our patch library is organized. We regularly build patches alongside filter builds. Our filters are updated hourly, and third-party filters are updated every 4 hours. Patches can be merged into one file for convenience in downloading. Patches are stored on the server for a week. If a patch isn't yet on the server, the module responsible for applying it will check for the patch after 1 hour. If the filter's lifetime has expired, it will be fully re-downloaded to ensure double reliability. When I talk about metadata earlier, I mentioned filter counters. These counters now play a critical role. They notify the user when and how much we couldn't fit within the browser's rule limit. To give the maximum amount of feedback and allow the user to address it, for example, by removing other MV3 extensions and decrease uses of this limit. And so my presentation comes to an end. I would like to talk more about what we were able to achieve thanks to the new manifest. Some improvements or new features we were able to implement. But as it stands, most of our work has been done in spite of, rather than thanks to MV3. We have focused on keeping the most important parts of our extension functional in the MV3 version, ensuring that it doesn't lose filtering quality. After all, Manifest 3 was envisioned as a tool for a safer internet. I hope that next year I will be able to talk about new interesting tools that will be implemented thanks to the work of Web Extension Commit Group and the openness to dialogue from browser developers. Thank you for your attention.